Hello everyone, welcome to Engineering Explained channel. In this session, I am going to discuss the applications of Bernoulli's equation. In the previous session, I have discussed the derivation of the Bernoulli's equation. I will take the what are the different applications are there where the Bernoulli's equations we are going to use. First one is that aeroplane wings and how the aeroplane flies. That is based on the Bernoulli's equation we can explain. The Bernoulli effect explains how an aeroplane wing produces lift. It is due to the curvature of the wing, that is the shape of the wing, that aerofoil shape we are going to call. Air moving above it has to move faster than air below it. And so, by Bernoulli, it has to have lower pressure above and higher pressure below. This is what produces the upward force lift. Here we can take this sketch to explain it. Here we can see this is the aeroplane and the aeroplane wing has have the aerofoil shape, and that aerofoil shape is like this. When the aeroplane is moving in the forward direction, the air is moving in this direction. During the airflow, the air moving above it has the higher velocity. Therefore, it has a lower pressure. As the Bernoulli's equation, the pressure and the velocity will be changing as the flow rate will be remain same. Therefore, here the lower pressure, higher velocity, and below the velocity will be lower and the pressure is higher. And due to that higher pressure at the bottom of the aerofoil shaped wing, the lift force is acting in the upward direction. That will cause the flying of the aeroplane in the upward direction. That is the application of the Bernoulli's equation. The second one is a venturi effect, where the fluid velocity increases when pipe narrows. The pipe diameter if reduces, the pipe narrows. Okay, its velocity will be increases. In varying cross section pipes, the pressure reduces. The pressure will be reduces as the velocity increases. This is an application of Bernoulli's theorem and is applied in carburetors, flow meters like venturi meter and orifice meter. We are going to use this venturi effect where the velocity increases at narrowed pipe and pressure will be increases, and atomizers where the mixing of the two the fluids taking place, that is atomizers we are going to call. Here we can see here there is a more diameter and it is having the particular velocity, and less diameter and the velocity should increase, and this a1 v1 is should be equal to the a2 v2. That is the called as a continuity equation. The continuity equation will be based on the principle of conservation of mass. The flow rate will be remains at the all the sections of the pipe flow, and that's why the velocity and pressure will be varied, and that variation we are going to take for the measurement of the fluid flow as well as in the carburetor in order to make the flow of the air as well as the petrol, and the atomization where the mixing of the two fluid taking place. That is the and another application of the Bernoulli's theorem. Third one, blood flow in arteries. Bernoulli's principle explains the reason behind how the pressure varies with the blood vessels with respect to changes in blood flow velocity as a result of constriction or a abstraction. The constriction or abstraction what are present in the blood vessels, how those will be causing the increase in the velocity and reduction in the pressure. The more speed at constriction results in reduced pressure. At the constriction, where due to the some deposition in the blood vessels, here the velocity will be more, and that will reduces the pressure. That will be reduces the pressure, and due to that constriction or deposition in the blood vessel, that will reduce the blood pressure, and that will cause some other effect, and that's why that blood pressure variation with respect to the velocity that can be calculated by using the Bernoulli's equation, and thereby the whatever the medical the treatment or something the medical process is there that can be carried out. The next application is sports, that is a football or a cricket. Here the Bernoulli's theorem can be used in trajectory of balls. For instance, a soccer ball is kicked with spin curves because of the difference in pressure created by the air velocity. That with turning with a spin, if you make of the flow of the this ball, that ball is thrown, and that will be turns due to the air velocity, and that spinning whatever is there, that will be changing, and what we can call in the particularly cricket the spin balls. Okay, the spin balls means whenever it will be turned, the air pressure will be changing, and due to that the ball will be turns curved path, and that is applied application of the Bernoulli's equation. The last one, water flow in pipes. The Bernoulli's equation in fluid mechanics is applied to analyze the flow of water in pipes of different diameters. The flow rate is constant, but the pressure and velocity vary with a change in diameter. Here the flow rate will be remains constant, whatever may be the size, inlet and outlet and all the sections. And here, if the smaller diameter is there, velocity will be more and the pressure will be less. If the larger velocity is there, the velocity will be less and the pressure will be more, and that will be causing the slower water higher pressure and faster flow rate lower pressure. Like that, with the varying velocity, the change in the velocity as well as the pressure energy taking place by keeping the flow rate constant, that is what we can call the conservation of mass or a continuity equation, and that is applied in this one, the Bernoulli's equation. These are about the major applications of the Bernoulli's equation. Thanks for watching. If you like, share, subscribe, and comment.